this course. Thank you very much.
Thank you, sir, for giving us the inaugural address. Now, I would like to give time to Professor Goutam Sutradhar and Director NIT Manipur to deliver the inaugural address. Over to you, sir.
Thank you very much. Am I audible to everybody?
Yes, sir. Yes, sir.
Yes, sir.
Am I audible?
Yes, sir. Yes, sir. You are properly.
Okay, thank you. At the outset, I really congratulate the electrical department of NIT Manipur, particularly Dr. Suma Udhikari and his team, and the coordinator of this particular program on emerging trends and developments in electric vehicles. I also convey my warm welcome on behalf of NIT Manipur to all the participants, experts from India and abroad, and my colleagues who are also involved in this. It is needless to mention that this topic is very, very relevant in this current context, and everybody knows that currently vehicle and other prime movers are being run by the fossil fuels particularly. So if this e-vehicle or electric vehicle comes by 2030, so there will be, which is our prime objective, is that from the India and other parts of the world. So it will be really very, very helpful for the next generation. And I'm sure that the 5-day program on emerging trend and developments of electric vehicles from today to 29th October, this 5-day program will be very, very helpful to all the participants. And not only that, I hope that the experts who are actually giving their talks, they can also share their knowledges with our very esteemed participants are there. So there will be, I hope that there's a good exchange of ideas, technical issues will come up. And I not only welcome, I really thankful to Atal Academy for sponsoring the whole program under the banner of that faculty development program. And I'm really very happy to see that there are about 13 resource persons are there, and out of that about 2 from abroad and 1 or 2 from our institute, and rest are from the eminent institutes of national importance. So I hope that the deliberation as well as the exchange of views will be very, very high standard. And not only that, the participants who play the key role in any program, I expected that at least more than 100 people are participating in this program. So I hope that this program will really have great success. And not only that, I say that after these 5 days, it will be the end of the beginning. So this type of courses, I hope that Electrical Engineering Department of NIT Manipur will continue to do it, because always we have to go on doing, keep on doing, to make the full awareness among not only the technologists but also the users. Okay, because the takers should understand the benefits of e-vehicle, and until unless they understood the benefits, and it is purely environmental free, though 100% environmental free is not possible, but at least we can say that electrical vehicle will run at minimum negative impact on the environment. So I hope that this kind of steps which you have taken, they will continue under the leadership of Dr. Suma Adhikari and his team for and the team for the future programs also. So don't stop here. Please continue this type of programs in future. With these words, I thought that I should conclude here, and I hope the full success and this program will be a grand success, I can say. And all the participants will really get some inputs after 5 days program. I am very sure about it. So with this, I leave this session. So thank you very much. I also interested to take part in few of the lectures, depending on my occupancy. I am very interested to know, though I am a mechanical engineer, but I know that what kind of interactions is going on between the electrical and mechanical and electronic system in the vehicle. Especially, I am very interested in automobile engineering. So that is why I hope that this program will continue to be not only by NIT Manipur, by other eminent institutes from the country. So we also take part, my students, my faculty members, my research scholars also take part in the programs which will be conducted by other institutes of our country and the globe. So with this, I want to leave. Thank you very much, Dr. Suma Adhikari and his team, and Dr. Kundan Kumar for inviting me to inaugurate this session, inaugurate this program. So thank you very much. Have a nice day to all of you. Thank you.
Thank you, sir.
Thank you, sir, for promoting us to organize this event in the future, as well as for delivering the inaugural speech. Now, I would like to give time to Dr. Sanjeet Dwivedi, Danfoss Power Electronics AS, Denmark, to deliver the research and innovative address. Over to you, sir.
Am I audible?
Yes, sir. Yes, sir. Yes, sir. You are audible.
Yes. So good morning, everybody. I take opportunity to share my first feedback that this course, which is organized by the NIT Manipur, that's very relevant, and I'm looking forward for my lecture, which is in the next half an hour. And the way composition of this course and guest faculties and expert invited from different institute. Thanks to Dr. Kundan for choosing such a high experience and knowledgeable persons among India, as well as giving chance to us from Denmark. And I wish that this course will be a grand success. And then looking forward to share my ideas in next half an hour. Thank you very much.
Thank you, sir, for enlightening us with the research and innovative, and we are looking forward to have the full session, sir. Lastly, I would like to give time to Ma'am Rajkumari Malengambi, Lecturer, Electrical Engineering Department, NIT Manipur, to deliver the vote of thanks for the inaugural function. Ma'am, over to you, ma'am.
Thank you, Boris. I think my voice is audible.
Yes, ma'am.
Okay. A very good morning to our Director Sir, Dean Sir, and all the faculties present. It gives me an immense pleasure to deliver the vote of thanks for this faculty development program. First of all, I would like to thank our Director Sir, Professor Goutam Sutradhar, for joining us today and delivering us a motivational speech to all the faculties and the participants present. I also would like to thank our Dean Sir, Professor Rajesh Kumar Bhushan, for attending this function with us. I also would like to thank Dr. Sanjeet Dwivedi, Danfoss Power Electronics Denmark, for joining today in this faculty development program. I would also like to thank our head of department, Dr. Suma Adhikari, and the coordinator of this program, Dr. Kundan Kumar, for organizing such a program. Lastly, but not the least, I would like to thank all the participants and all the eminent experts present here. Thank you.
Thank you, ma'am, for the beautiful board of things. Now I will refer my mic to the Dr. Kundan sir.
Thank you, Boris, for your support, and thank you all the eminent persons, chief guest, Dr. Sanjeet Dwivedi sir. Okay, we will be starting our first session at 10:30, just after the common inaugural function of Atal. So this meeting will be on. All the participants can be stay here, as well as you should watch that. I think you must got the link for the joining the common inaugural function. And again, I will share in the WhatsApp group that I have created. So, okay, just I may request to everyone, kindly turn on your video for a while so that I could take some snapshot. Okay, please, if you can do. So basically, we'll start our first session at 10:30. For that, in between, you may join the inaugural common inaugural session there. Sanjeev sir, if you are busy, so after this photo session, you may take rest, sir, for 30 minutes, and you can again join at 10:30, sir. Thank you so much for your precious time, sir.
Most welcome, Dr. Kundan.
Thank you, sir. Okay, thank you so much to all the members present here. So now we'll meet again at 10:30 with this meeting link. So you may connected here, no issue. Start our first session at 10:30. And also I request all the participants to join the common inaugural session of Atal, which is very important. Thank you. Thank you so much. Thank you, Boris. Good morning, sir. Shall I start, sir?
Please start, Dr. Kumar.
Okay, sir. Just I'm starting. Okay. Once again, very good morning to one and all present here. Today, for the first session, we have with us Dr. Sanjeet Kumar Dwivedi, sir, who is a fellow of IEEE UK and senior member IEEE, and he is working as project leader and senior research scientist in Drive Intelligence team at Danfoss Powertronics Global R&D Fredson, Denmark since 2008. He is contributing for research for green technologies and their industrial applications in power electronics and motor drives. Prior to this, Dr. Sanjeet was an electrical engineer in Larsen and Turbo, India, 1991 to 1992, and faculty member of the Department of Technical Education, MP, India, 1993 to 2001. He worked as research associate in power electronics, electrical machine, and drives research group of Indian Institute of Technology, Delhi, during 2002 to 2006. Toward his doctoral research, he worked as head of the EE department and dean academic at Indira Gandhi Engineering College, Sagar, MP, India, during 2007 to 8. Dr. Sanjeet has awarded with 2 master degrees. First one from Indian Institute of Technology, Roorkee, India, Master of Engineering in Power Apparatus and Drives, and second one from South Denmark University, Elsen campus, Sonderburg, MSc Engineering in Innovation and Business, Denmark. He has completed his PhD degree in motor control from Indian Institute of Technology, Delhi, India. Dr. Sanjeet also completed his executive leadership education from MIT Boston. He was honored with adjunct professor at Curtin University, Perth, Australia, 2016 to 2018. Dr. Sanjeet has authored more than 40 technical papers and holds 7 international patents and 2 engineering research books published from Academic Press UK and IT Press UK. He is a member of the editorial board of International of Electronics, associate editor of the IEEE Transaction of Industrial Electronics. He has given invited presentations, organized and chaired special sessions in several IEEE and European Power Electronics conferences. Previously, he worked as associate editor of IT UK Power Electronics Journal, associate editor of Korean Journal of Power Electronics. Dr. Sanjeet was awarded with gold medal for his Master of Engineering degree at Indian Institute of Technology, Roorkee in 1999. He is a recipient of Merit Award from Institution of India, IE, 2006 in 2006 for his research publication on permanent magnet machines. He was also awarded with 9th Man on the Moon Global Innovation Award of Danfoss in 2015 and IET Bimal Bose Award in 2017 for outstanding contribution in power electronics and drives. With this, once again, I welcome you, sir, for this first technical session. Thank you so much, sir. Please go ahead, sir.
Am I audible?
Yes, sir, you're audible, sir.
So, welcome to all participants, and thank you very much, Dr. Kundan, for such a nice and explanatory and detailed introduction. Once again, so kind of you.
Thank you,
So
sir.
I will share my presentation, and please check if you are able to see the slides. And
Yes, sir. Please, you start sharing, sir. I am making you as a co-host, sir, or presenter.
can you see the slide is changing?
Just have you shared, sir?
Yeah, I said.
Is it not visible yet, sir? No, it is coming.
What
Sir.
about?
No,
Okay.
it is coming, sir. Yeah, it is
Yeah.
coming now, sir. You may check, sir, once. You can move one
Yeah.
to last. Yeah, it is changing, sir.
Okay, that's good.
Thank you, sir.
So I will not go in this introduction because Dr. Kundan already covered it. But I will mention two things. One is this my email. So participant, they can get connected with me, and they can also go to my home page and connect there also. And I will emphasize here my field of interest, that is control engineering, control of electrical drives, drive intelligence, and condition monitoring of electrical machines. And now I'm also working in the area of green energy and green energy technology through power electronics and drive. You can see this is my workplace, and the place name is Gråsten, and it is the summer capital of Denmark. You can see in the background somewhere here my office is. This is my company headquarters. I will introduce little in a while. This is the Danfoss headquarters in Nordburg, and we are having 3 divisions. One is power electronics division, which is situated in Goutam, and then we are having climate solution, Danfoss power solution, and we are having our headquarters also. This is 11-story building you can see here, and in the background you can see beautiful Baltic Sea. And just to name about this Danfoss, they are pioneer in cooling technologies. Somewhere in 1936, they did the breakthrough research in expansion valve, and then again in 1968 they did research, and first time they control the induction motor by power electronics. So variable speed control they achieved way before Siemens and ABB. So you can name they are the first mover and inventor of PFD. We are 100% focused on developing, manufacturing, and supplying AC drive. And Danfoss Drive is the world leader and first mover in variable speed control of electrical motors. As I told you, since 1968, VFDs have been our business, our focus. And in 2014, another milestone comes in the history of Danfoss, when Danfoss and a spin out of ABB Wacom, they merged together and they formed the world's largest companies in the VFD industry. Together, we will continue to be driven by a passion to develop, manufacture, and provide the most versatile variable speed drive in the world. Just to showcase our capability, we can adapt to any motor technology and supply product in a power range of 180 watt to 5.3 megawatt, and even more. You might see in a few days back that the Danfoss electrification division, they have provided, they are going to be install a 20 megawatt electrolyzer plant for green hydrogen generation. So, and power, because of the parallel connection of drive or parallel unit connection, power is not a limitation. As well as we are also in the medium voltage drive business also. Just to talk about this presentation, although it is specifically on the technology trend in EV, and I will share with you some novel concept, state of art in the drive technology, what is going on in the EV area. But as a background, we will talk about the global trend in e-mobility. And you know that e-mobility without green technology, that is not a you can say sustainable solution. So we will little bit deep dive in the green technologies also. I will share some numbers and some technology trend and some what is going on in the solar industry, wind energy industry. and green hydrogen industry. Then we will go through the recent trend in power electronics research. I will specifically talk about the energy efficiency in the electrical drive and how can we researchers take advantage of it, and then how can we contribute for green energy portfolio with this increased efficiency of drive. Then we will talk about trends in motor technology. I will share with you different type of motors and how they are affecting the efficiency of electrical drive and what is the latest trend in terms of motor technology. Then we will go through the conventional control. Maybe we can skip it depending on the time, but I would like to emphasize here that there is a latest trend in motor type technology where we are talking about conventional synchronous motor, but in contactless fashion. So we will means nowadays there is a GM and BMW. They are using this contactless synchronous motor technology for their drive and for EVs. So we will talk about this technology also. In the end, conclusion and question and comment. And I have to leave sharp at 8:30, so we will organize it that we must have some few minutes, 5 minutes, 10 minutes for question and answer. So what are the global mega trends which are transforming our world? They are started with the urbanization. We see that more and more population is shifting from villages to cities, and that is demanding a lot of energy and lot of resources and then lot of effort from technology expert and engineering expert. And this urbanization is related with the food supply and the climate change. As you know that we are having limited food supply, and if you count if you convert the energy uses, equivalent energy uses in the food supply chain, that we can have a scope of total global energy consumptions by any means, electrical, heating, or fossil fuel-based energy use. If we can improve our food supply chain, then we can save around 40% energy. So there is a big potential for transforming our world through food supply, improve food supply. And as you know that electrification, that is the future because of efficient energy conversion, and as well as there is a inherent advantage. We'll talk about it later, but there are many inherent advantages of electrification, because one of the major driver is it can easily coupled with the green energy, and then we can smooth out load variation on the grid, and as well as we can take advantage of seasonal energy sources and coupled it with the electrification journey. And then these all areas, they are connected, well connected with the digitalization. So by digitalization, we can do the analytics, and then we can improve their performance, and we get most out of it. So all in all, there are 5 global mega trends, and Danfoss is having presence in all 5 global mega trends. I think there is some disturbance here. How can I move this bar?
Yes, what happens, sir?
This bar I want to move because it is hiding my headings.
Just you may drag it somewhere, sir. Is it something like that? Actually, we can see your screen now, sir.
Yes, now it is okay.
Thank you, sir.
So, a way of sustainable world, that is the e-mobility. And why we are saying a way of sustainable e-mobility, why this is needed. As we know, in 2015, through Paris Agreement, nations around the world agreed that rapid decarbonization is needed to prevent the dangerous impact of climate change. And subsequently, in 2018, the Intergovernmental Panel on Climate Change, IPCC, its report saying that global warming of 1.5 degrees centigrade shows that the need to cut greenhouse gases emission is even more urgent than previously thought. And then the window of opportunity is closing fast for meaningful action to limit the planet increase in temperature and to counter the global climate crisis. Therefore, policymakers must increase their effort to reduce or eliminate emissions in all economic activities. Option that would deliver only partial emission reduction is not enough. The full decarbonization of some industries and transport subsector is technically and economically challenging, and the current number of solutions is limited. These are known as hard to abate sector. There is, however, a common solution for some of these hard to abate sectors. For example, hydrogen produces with renewable energy, also known as the green hydrogen, that is a good substitute. So why e-mobility? First of all, zero emission. This type of e-vehicle that neither emit tailpipe pollutant or nitrogen oxide. The manufacturing process tend to be more respectful with the environment. Although battery manufacturing that have some adverse effect. Simplicity, the number of electrical vehicle engine elements is smaller, which lead to be much cheaper maintenance. The engine are simpler and more compact. They do not need a cooling circuit, and neither is necessary for incorporating gear shift, clutch, or element that reduce the engine noise. So that is one of the major advantages. We can reduce the part count. Reliability, that having less and more simple component makes this type of vehicle have fewer background. In addition, EV do not suffer of the inherent wear and tear produced by engine explosion, vibration, or fuel corrosion. Cost, the maintenance cost of the vehicle and the cost of electricity required is much lower in comparison to maintenance and fuel cost of traditional combustion vehicle. Please note that when I'm talking about cost, then it's a lifetime cost that is quite lower than conventional vehicle. But this initial cost is still that is quite a factor, like 1.5 to 2. There is a extra cost for this EV and e-mobility. The energy cost per kilometer is significantly lower in EVs than in traditional vehicles. Comfort, that is quite high because of the absence of vibration or noise, engine noise. Efficiency, that is well-to-wheel efficiency is double as compared to conventional gasoline-based vehicles. We'll talk about it later. So, by contrast, EV fed by a natural gas power plant shows a well-to-wheel efficiency that ranges from 13% to 31%, whereas EV fed by renewable energy shows an overall efficiency up to 70%. Accessibility. This type of vehicle allows for access to urban areas that are not allowed to other combustion vehicles. EV do not suffer from the same traffic restriction in large city, especially at high peak of contamination level. Interestingly, there was a recent OECD study that suggests that at least in terms of particulate matter emission, EV will unfortunately not improve the air quality situation. So, how this electrification journey can help us? Replacement of traditional combustion engine or hydraulic drive with electrical drive. that can impact a wide range of sectors. They're in automotive, marine, machine building, heat pump. In some sectors, for example, marine, industrial drives are used directly. In other applications, automotive drives are customized due to the space, cooling, and reliability requirement. The e-mobility industry is moving fast. There are some statistical figures. Today, the transportation sector accounts for 25% of all CO2 emission in Europe. By 2040, more than 50% of all cars will be electric. Ferries, truck, and other vehicle also going electric. This is the red line or red light for converting conventional vehicle to electrical vehicle. But as you know, in Norway, deadline is very close. In 2025, Norway already declared that they will replace all conventional vehicles with the EVs. And Denmark and other European countries, they also given a deadline of 2030. So this is the worst number. But in the next 20 years, we'll see that we are not having conventional gasoline-based car. And for example, Volkswagen, they say that last generation of combustion engine will be launched in 2026. They declared it already in 2018, and maybe due to the COVID,
Excuse me,
this
sir.
date is report. Hello.
Sir, your slide is not changing.
Thank you very much for telling it. What about now?
No, sir. The slide is using the review of for sustainable, the 2015 Paris Agreement slide.
7th slide is there, sir. You may stop sharing and just use reshare again, sir. That will be.
Okay, thank you. Thank you very much for your comment. Who is this? Who made this comment?
So one of the MTech students, sir.
Yeah, say him thanks. My thanks to him.
Yes, sir. No, you may reshare again. Reshare again, sir.
Can you
Yes.
see now?
Yes, sir. Yes, sir. It is coming, sir. Okay. Thank you, sir. Please go ahead.
Now you can see the text.
Yes, sir. Yes, sir. Now it is the e-mobility industry.
Yeah, it's moving fast. Yes. Thank you very much. So we see that today the transportation sector accounts for 25% of all CO2 emission in Europe. And by 2040, more than 50% of our cars will be electric, ferries, trucks, and other vehicles also going electric. And this is the conservative number. So you say that way before this will happen. And then COVID also accelerated this journey. So as Norway declared in 2017 that by 2025 they will be only running with the EVs, electrical vehicle. So and then Denmark and other European countries, they declared by 2030 they will eradicate all fossil fuel based cars. So this is a conservative number. You'll see that way before this will happen. And India is also in the signing path. And we see that a lot of things are happening in the charging infrastructure. There are multi-players, and they are producing EVs, and we see that a lot of new startups and other companies are also working. So this e-mobility industry, that is the future, and we will see this transformation within a decade. I would say that. And conventional gasoline-based car engine, they will be the story of yesterday's, because we see that one of the biggest manufacturer of gasoline-based car engine, Volkswagen, they declared that they will launch the last engine in 2026. So why all electric transportation? When we say the electrical mobility, then it is for road, for water, and for air, all three. And there are some nutshell. You can say that fuel economy is the driving factor. Low emission, that is also a factor. Fuel cost saving. There is a less expensive fuel to operate than conventional vehicles. Energy security, as our beloved Prime Minister says that we need to make India as a hydrogen economy, and there is a how many billion, 100 billion US dollar that is also earmark in next few years that we will get country self-sufficient in terms of importing petroleum, and then we are making our country to based on the green energy economy, and that is coming through energy security, and e-mobility is supporting that. Fueling flexibility, that this is the one of the major driver. You see that this will open up new avenues for the business. We cannot see right now this, but imagine that how can we support our rural population? Right now, it's very difficult to provide gasoline-based fuel to in the remote areas and even in the villages, and controlling the price for that. But imagine, due to the green energy and the EVs, every remote village that can have capability to fuel their own fueling station. So by charging at home or public charging stations, that will be a game changer. Of course, we need to consider the purchase cost and public charging infrastructure, battery recycling and reuse when we are talking about all electrical transportation. But these are the open questions for we scientists to solve. And we are, as a teacher or technology leader, we are having extra responsibility to find the solution for these questions. As I told you, well to wheel efficiency, we will go through these numbers. We can compare that oil is used in the oil or gas is used in the electricity generation plant, and then transmission of this electricity, and then charging to the car, and then using the EV. So this is one circuit here. We are using the fossil fuel, and then in order to compare the wheel to well to wheel efficiency. So this is one circuit for e-mobility, and another one is oil is used in refineries, and then gasoline is distributed to the conventional petrol pump, and then this gasoline is fed into the conventional car, and it is converted for the motion. So generation, that is having 33% efficiency, transmission system 94% efficiency, that is well to tank efficiency 31%, and plug to wheel, that is 76% from charging to the car terminal. And then overall efficiency, that is well to tank is 31% and tank to wheel is 76%. So overall efficiency is 23%. When we compare it with refinery, that is 82%, transmission 98%, so overall efficiency is 80%, but the pump to wheel, that is very low, that is 16%. So overall efficiency is 13%. So we say that if we are using even the fossil fuel, then we can get a 100% increase in energy efficiency. What if we are not using fossil fuel at all, and we are using the green energy or renewable energy? Then you see that how much we can save in terms of energy, and how much we can save in terms of decarbonization journey. There are some numbers where Bloomberg estimates a significant increase in electrical vehicle from 2020. They say that annual global light duty vehicle sales, and here internal combustion based engine battery energy vehicle, plug-in hybrid electric vehicle, and all EVs. So this pattern is showing very interesting phenomena. You see that this IC-based car, they are going to increase, but they will stay at constant value, like 100 million vehicle at or 105 million vehicle at some point of time. But all EVs, which are very tiny in number at present, but they are having exponential growth, and they will supersede in the market. And another interesting part, this plug-in hybrid electrical vehicle, which is a practical solution right now because of the consumer having a fear that for the charging cycle and the capability of batteries and other things. So they are having this dual mindset that both fossil fuel based and EV based vehicles are they want to prefer, but this is not going to be sustained in the future. There is a pure battery electric vehicle, that is the reality, and we'll see this journey more and more. So always a question of belief, if it is a 5, 10 or 20% in 2025. Number shows that in the last 2 or 3 years, there is a 400% increase in EV penetration in some countries. So we cannot say any at this point of time any fixed pattern or any calculated rate, but this exponential growth will be higher and higher. So what are the technological challenges with e-mobility? First of all, that is the driving range. We know that this is full charge capability, that is a issue, but this is under continuous improvement. We know that Model S of Tesla, that is capable of running 500 kilometers in one charge. And charging time of battery pack can take 4 to 8 hours. And even a fast charge to 80% capacity take up to 30 minutes. For example, Tesla supercharger can charge the Model S up to 50% in only 20 minutes, but remaining 30% in half an hour. And the battery cost, that is a limiting factor. And this is a technological challenge which technical fraternity need to solve. Bulk and weight, battery pack, they are very heavy, and then they take considerable vehicle space. And please note that this battery is the most vulnerable component in the entire EV. So there is a safety measure and battery energy management, that is also a high focus research area. It is assumed that the batteries of this type of vehicle have an approximately weight of 200 kg, and which can vary depending on the battery capacity. So there is a rough number that 200 kg is only needed for a if we need a long driving range, then we need to spend off 200 kg weight for that. This diagram that is showing what are the technical challenges with the e-mobility. You see that nicely explained here, that batteries, there are new challenges in the batteries. We'll talk about it later. Power control and energy management. There are also use of artificial intelligence and communication protocol. That is also a challenging area where a lot of new things is happening, but is still a lot of scope for the technology improvement. And charging. So connector type and different mode of charging, we will address them later. So eco charge and AI-based charging and improvement in the charging process. So these are some of the technological challenges which we need to solve. These are the capacity of different vehicle manufacturer battery technologies, and I have taken only few, and from in this slide from 2017. But you see that dominate here, Tesla Roadster that is dominating with 200 kilowatt of our battery capacity, and they offer in the next year. And all other they are way below and within 100 kilowatt hour capacity. So this is the trend. And if we see here, evaluation of battery capacity since the mid 80s and until now, we see that here in the y-axis you need to read it kilowatt hour. Yeah. So from tiny number from 10, 20 kilowatt hour up to it in 2020, most of the EV manufacturer they increase their kilowatt hour capacity to 100 kilowatt hour, and of course Tesla is a little higher, and they are driving the market towards more higher capacity. And here you can see different type of battery technologies and how they are placed in terms of durability. So how many charging cycle that they can take place, and then what is the energy density of different technology in terms of watt hour per liter volume. So of course, this lead and lead oxide battery, it's in the bottom corner. But the other, this sodium and nickel chloride and nickel cadmium, zinc bromium, and then sodium sulfide and lithium ion. You see, this is research is more and more research is going on lithium ion, but that's my own view that we need to find a next type of technology because full focus is on this, and here we have reached already to a saturation point. So we see that there is a lot of scope in the battery technologies, and we power electronics engineer together with chemical engineer and material expert and of course AI expert, we need to work together for solving this battery technological challenges. For charging of EVs, there are North American standard for electrical connector. They have created in 1996 and supported by SAE International. This standard is common in USA and Japan, and it establishes the following charging mode. Just to share with you that in India, we make a framework for charging infrastructure, and our standards they are also going to be imposed in a couple of years. Maybe they will out this year for review, and they will also follow these guidelines. So there are a different charging mode, as you know, 2-level in AC supply and 2-level in DC supply. So standard electrical outlet that provide voltage in AC of 120 volt, offering a maximum intensity of 16 ampere. That is AC level 1, and AC level 2 is there with the 240 volt AC supply, maximum intensity of 80 ampere, and offering a maximum power of 19.2 kilowatt. And DC level is with 500 volt DC and maximum intensity of 80 amp and a maximum power of 40 kilowatt. And DC level 2 with the same voltage but 200 amp and 100 kilowatt. So these are the SAE standard J1772. You see that voltage, current, and maximum power. And IEC 62196 standard is an international standard created by International Electrotechnical Commission for charging electrical vehicle in Europe and China. And this IEC established the general characteristics of the charging process, as well as the way in which the energy is supplied. This norm derived from the IEC 61851, and it provides a first classification of the charging type according to its normal power and thus of charging time. Users are provided with the 4 modes in order to charge the vehicle. So you see this mode 1, mode 2, mode 3, and mode 4 with the maximum current. According to this standard IEC 62196, there is a small difference, but almost in this standard, there are first 3 modes are AC supply, and last mode is the DC supply. So according to this IEC standard 62196, mode 1 is the slow charging, mode 2 is the semi-fast charging that can be defined maximum intensity of 32 ampere, and it uses standardized power outlet with phases, neutral and protective earth conductor. Mode 3 is with the fast charging. It provides an intensity between 32 amp and 250 amp, and this charging mode required the use of EV supply equipment, EVSE, a specific power supply for charging electrical vehicle, and it provides communication with the vehicle, monitor the charging process, incorporate protection system, and stop the energy flow when the connection to the vehicle is not detected. I think this is the most appropriate one, and in India, when we are talking about charging infrastructure, that is the minimum for us. So that's also in our framework and guideline. This mode 3 is the main driver, and mode 4 is the ultra fast charging, and that is defined a direct connection of the EV to DC supply network with a power intensity up to 400 amp and maximum voltage of 1000 volt and up to a 400 kilowatt. And please note that these modes are required an external charger that provide communication between the vehicle and the charging point, as well as protection and control. So what is the technology shift and advances? Emergence of advanced technology, computing and software technology in e-mobility. This slide nicely covers it. The rapid development of digital technology that is reshaping the automotive industry as a whole on different levels. The 3 innovation levels affected by the technological shift: vehicle innovation, production innovation, and the new business model. When we are saying vehicle innovation, then car connectivity and autonomous driving. That is the technological development. And production innovation, then these smart factory and industry 4.0 application. And new business model, so we talk about after sales service, new car ownership model, and on-demand mobility services. If we talk about these innovations, e-mobility connectivity is possible through technological advancement in the collection and processing of data, which is then shared and connected to other vehicles. This innovation enables a safer and more convenient mobility, as well as new service, such as automated emergency call in case of an accident, real-time hazard warning, repair diagnostic, and optimized route planning. E-vehicles are increasingly equipped with system generating data, install sensor, brought in sensor through mobile devices, and system for information and entertainment. According to studies, connected e-vehicles are generating up to 25 gigabyte of data per hour. Autonomous driving is enabled by fast progress of smart sensor, computer vision, machine learning, and artificial intelligence robotics, global position, high definition map and connectivity. Currently, many new e-vehicle model offer assisted driving system. For example, vehicle motion control, speed keeping, or assisted parking. The rapid development in the possibility of vehicle automation offer promising future prospect. There are some figures. The European automotive industry expects revenue of over 620 billion euro in the market of connected and automated vehicle by 2025. This is a huge revenue. If you remember, I talk about growth of EV in the worldwide consumer market. You see here these numbers. Norway, they were having a market share of 6.1% in 2013. But you see that how it is increased. Now they are in 2020, they are having EV share is 55.90%. So more than half cars they are having electrical vehicle in Norway. So, and then you know that they set a deadline for 2025 and it is not far away. Same Iceland, you see it started from 6-7 years from a tiny number of 0.94%, but reaches to 45%. Of course, Iceland is a very small country, so we can see this number, but let's look into Sweden. That is also started from tiny number until few years, 2 years, 3 years ago, but it's 1/3 of their vehicle are now EV. Same for other countries. For example, Denmark. You see this journey started from 0.29% or 0.3%, and it's reached to 16.4% already in 2020. United Kingdom, it is like 45%, and China, it is 5.4%. But in terms of total car number, I think they are the number one in the world, because this 5.4% is a huge number for China. Japan, that is still on the lower number, but Japanese EV manufacturer, they are driving this transformation, and all the Japanese EV manufacturer, they are contributing for this technology. You name Toyota, you name any other company in the EV industry by Japanese industrialists, they are contributing for it. This slide is showing you EV cells country-wise, and here you see green color is showing 2016 and before, blue one is 2017, yellow one is 2018, and dark green is 2019, and dark blue is 2020. So, and how many thousand vehicles? So you see that China is having only 5.4%, but still this is the huge number. USA is also having very low percentage, but in terms of total vehicle number, they are quite high. And here also you see there is a trend that in EV cells worldwide is increases compared to previous year. So, and then due to the COVID, post-COVID effect or post-COVID learning, we see that in order to make a safe future and a sustainable future, this consumer awareness and government directive will also promote these EVs around the globe, and we will see these figures will going up. So if we talk about EVs, e-mobility, and then how can we take best advantage of it? So that's only possible if we can drive by electricity, and Why? Because if we compare these electricity on different energy sources, we see that cost saving by electricity is around 75% compared to gasoline. There are comparison with ethanol, hybrid, diesel oil, biodiesel, LPG, your natural gas vehicle and electrical vehicle. And we see that there is a huge potential of 75%. But there is a dependence how this electricity is generated. So if we generate it with green energy or green sources or renewable sources, then not only the price will be, cost will be less, but we are having less challenges for our CO2 emission. And for that, there is an alarming issue of climate change. As I told you earlier, the window of opportunity is closing fast for meaningful action to limit the planet increase in temperature and also to counter the global climate crisis. The future of e-mobility is the green energy. There are some interesting numbers. Average CO2 emission from new passenger car registered in the European Union in 2025 will have to be 15%, and in 2030, 30% lower compared to 2021. So if we compare with 95 grams CO2 per kilometer, these number will have 15% and by 2025 and 30% by 2030. And how? By the green energy. So we'll see that this global warming and other after effect of fossil fuel waste energy that creating a thrust or demand for widespread use of green energy, and electrical power system that is sustainable and that augment the centralized and large grid-based dependent system of today with distributed small scale, smart grid-based energy generation system that is the future. And to achieve this, world will increasingly adopt renewable energy sources. And power electronics is essential for harnessing energy from solar, wind, fuel cell, and other green energy sources. Converter, inverter, and solid state transformer, they are the essential component for this journey. An electrical drive plays an important role in increasing energy efficiency of electrical power generated worldwide by conventional or green energy sources. So, future of green energy system that necessarily deliver on the three dimensions. Say, providing safe, secure, and reliable energy while delivering access to all energy consumers, supplying energy at affordable price, and assuring sustainable development. If we talk about future green energy system, then that involve massive changes in technical and organization level, and it needed considerable effort, and these actions constitute a huge science and engineering challenge. And this must be economically, environmentally, and socially viable solution while meeting high security requirements. This is a green energy system for future where we see that at distributor end, we can have a rooftop solar plant instead of secondary customer who are consuming the load, and then for generating station we can have a wind power plant or solar power plant. If we see if we compare the cost of different energy sources, interestingly, we can find that rooftop residential installation cost that was $184, that reduced with the thin film utility scale to $43, and wind energy that is further reduced to $32, and biomass compared to this is $82, and fuel cell is still a little higher, $106. And so this cost, which is coal, if we say the basis cost per megawatt hour $65, we can see that wind and solar, they are lower, they are having a lower cost for per megawatt hour. So this renewable energy is no longer a luxury, it is a cost-effective solution. And that's why we see that worldwide more and more effort are going on, and India is also having a goal for reaching to 400 gigawatt of renewable energy in next 5 years. Already reached to 100 gigawatt renewable energy till date. I will not talk much about this slide, but you see that the future green energy for smart city, and that is relying on EV infrastructure that is part of this smart grid for smart cities. So battery storage and off-grid vehicle and vehicle-to-grid charging, that is part of this smart grid, which is, a smart microgrid is local, it is independent, and it is intelligence. Now, a question comes in our mind. What is the secure energy source for next generation? We must have some quantified data to compare different types of energy sources and see that who is the winner. So in 2009, worldwide energy requirement was 16 terawatt year per year. You know that kilowatt hour, instead of there is a terawatt year, that is the unit for worldwide energy consumption. And rate was 16 terawatt year in a whole year. That is increased by 75% by 2050. And world will demand 28 terawatt year energy per year. How can we meet it? So fossil fuel reserve, we are having only 900 terawatt year. Uranium can be from 90 to 300. Natural gas up to 250. Oil 240. And renewable energy per year, hydro is only 3 to 4 terawatt year. Wind, that is 25 to 70 terawatt year per year. But look in this solar, and these bubbles are showing the energy requirement. And all energy sources, bubble wise, they are showing a proportional potential. So if you see that potential of solar energy, that is huge, huge. And that is why India is already leading on this green energy initiative. We set our International Solar Alliance, and I will show you some numbers. That's world highest capacity solar plant. They are installed in India. You see here, they are the top top capacity solar power plant around the world, and you see 3, 4, 5. They are already in India, and the highest capacity plant is also in India. So we are driving. We are the front runner in this journey, harnessing the solar energy and changing making a secure environment for our future generation. This graph is showing a growth of primary energy from solar power plant, and here this concentration is more than 1.2%, and you see India is in this map very well connected. And if you see the cumulative growth of solar power plant in gigawatt, then it is increasing exponentially again. And number of 1 gigawatt power plant capacity of 1 gigawatt and trend is going on for high and high capacity plant. So if you see that top 10 of total installation market, then it is market is not going to decentralize power plant, solar power plant. They are interested in making a big gigawatt capacity plant, and most of the solar power generation is transforming in that way. That most of the installation that are having a big capacity. And the driving factor is solar photovoltaic multi-module price variation. You see the price is reduced from $0.63 per peak watt to $0.19 per peak watt. So there is a fourfold decrease in the price. That is also driving the penetration of solar photovoltaic multi-module plant. And if we compare renewable energy sources on carbon neutrality, then we can find that coal, which is producing 1 kg CO2 per kilowatt hour, then wind is only producing 10 grams CO2 per kilowatt hour. And photovoltaic, that is producing 40 grams CO2 equivalent per kilowatt hour. So we see that wind is 100 times cleaner and solar is 25 times cleaner. Let's look on some number. Wind energy conversion, that is fastest growing source of new electricity generation in the world. And coincidentally, Denmark is leading this wind energy technology with Ørsted and Vestas as the biggest player in this wind energy market. At the end of 2010, the installed wind capacity stands close to 200,000 megawatt, doubling since 1999, and reaches to 800,000 megawatt by end of 2021, observing a growth of 10% each year, and 5% of world electricity comes from the wind power. These are some numbers where you see from nowhere in 1981, it increases to around 700,000 megawatt in 19, and expected figure is 800,000 megawatt. And what are the recent trends? Harnessing wind energy for electrical power generation is an area of great research interest. Power capacity, that is increases in terms of turbine and generator, 20 kilowatt to 12 megawatt. A lot of different concepts have been developed and tested. And important issue is the wind turbine efficiency, because that if efficiency is reduced, then we are reducing our income. And obtaining the maximum power output for varying speed, that is also a concern. And generator adaptation, that also taken into account. And generator choice is based on the turbine size and the wind class. So if we compare different generator technology, W-fed asynchronous generator or permanent magnet synchronous generator, or superconductor based generator, There are some prototype and a test pilot plant which are the capacity of 10 megawatt, and they are in development stage where stator winding is done by a special arrangement where winding is cooled by external circuitry and achieving a superconducting stage to reduce the losses. And trend is now shifting towards the specialized design for higher energy efficiency. This slide is showing some renewable electricity generation by energy sources. We see that in 2019, the total amount of electricity generated from renewable is around 6,963 megawatt, and hydro is 61%, wind is 1,412, and solar is 690 terawatt hour. Bioenergy is in the same range, and geothermal energy is 92 terawatt hour, and marine energy is very tiny. It's around 1 megawatt hour. So if you see in the numbers, you see that wind that is having a 12.3% rate, and then solar is around 22.7% increase rate, and then hydropower and bioenergy that is next to it. So most of the renewable energy that is till now that is coming from the hydro, and then next is 20% through wind, and 8% bioenergy, 10% solar, and 1% geothermal. So there is a huge potential in solar, wind, and bioenergy. These are some numbers showing renewable electricity generation by region. I will skip this slide. And there are some rationale why green hydrogen. So green hydrogen is very well placed in terms of carbon neutrality. It was predictable that green hydrogen should receive a new wave of attention from government, policymaker, energy sector stakeholder, and even the general public, and it's already happening. We have seen that Denmark and India initiative for green energy strategic joint partnership, and it is mainly for hydrogen economy, and unprecedented number of report, article, webinar, event in last 2 years that touch upon the topic, and development of green hydrogen sector is itself still at a very early stage, but gaining a momentum. Each year, around 120 million tons of hydrogen are produced globally, mostly from fossil gas and coal, that is grey hydrogen, and which together account for 95% of global production. Hydrogen used for crude oil refining and ammonia and methanol synthesis represent almost 75% of hydrogen consumption. And you see that there we can make a difference, and we can make decarbonization journey in a more promising way if we can replace this grey hydrogen by the green hydrogen. And roadmap describe International Renewable Energy Agency World Energy Transition Outlook that include a major role for green hydrogen in reducing greenhouse gas emission and making the energy transition possible. And please note that with the hydrogen in e-mobility sector, we'll see a great shift. So you can say because of energy density or volume per kilowatt hour volume of hydrogen that is quite a positive factor in terms of conventional battery or conventional or present day batteries. So then hydrogen is having a huge, you can say, opportunity. It creates a huge opportunity for e-mobility. And this global supply chain and green energy sources, they together make a big impact. And you are going to see that for a country like India, where we are having a initial cost, investment, infrastructure that is having an issue, there we can club the solar and wind energy with the hydrogen production, and this e-mobility will get a wing to prosper. And in a coming year, we will see a lot of initiative from governmental level and from the private sector, where we see the research, and we technologists, we are having greater responsibility, and we are having a greater role for making this green energy, green hydrogen viable and a practical solution for the e-mobility. These are some numbers, and then that by 2050, green hydrogen need to have far greater dimension than today. So producing that much in turn would require significant scale up of electrolyzer, with total installed capacity growing to 5 terawatt by 2050. The electricity demand to produce hydrogen reaches close to 21,000 terawatt hour per year by 2050. I was looking for some presentation of this ITM Power, who is the global manufacturer of electrolyzer. They were saying that they are having a capacity of 1 gigawatt of electrolyzer, so produced by their plant. So you see that how much time they need to meet this requirement. So we will see that a lot of research or a lot of startup, a lot of companies will going to install these electrolyzers and to produce these electrolyzers, and their optimization in terms of install capacity, their technologies, and their wide scale uses. We'll see a lot of efforts are needed for that, and we in India, we also driving this journey. Policymakers then have a central role to play and already have the tool to meet the challenges. Some countries have already introduced a hydrogen strategy and implemented initial policy to support the sector, and target policies are being drafted. And as I told you earlier, India has already taken a lead on it. Still, the sector need to move from niche to mainstream. More diffuse policy and measure will be needed, and policymakers today can draw early lesson from the trailblazing country in the green hydrogen sector. These are some production and value chain of green hydrogen, and I will just say that this production can be from renewable energy or from conventional electricity, and there we need electrolysis to produce hydrogen, this green hydrogen, if it is from renewable energy, or if it is from conventional electricity, then it is gray hydrogen. And then we need to transport by shipping, truck, or pipeline, or we can need a storage, and then transformation. This can be used by without transformation or with transformation. When we are talking about with transformation, hydrogen is converted to synthetic fuel, or this hydrogen is converted to green ammonia. And in the end use, it can be steel industry, chemical industry, or refineries who use this hydrogen, or transport sector, shipping, aviation, cars, rails, trucks, or buses. or this is used for the heating like in UK homes, or it can be used for power generation. This slide is showing some interesting fact about production cost. So hydrogen production cost depending on the electrolyzer system cost, electricity price and operating hour. So if we say that electrolyzer system cost is around $770 per kilowatt plus fixed cost, you see that we need at least 8,000 hours to reach this $1 to $2 per kg price. But if price is around $500 per kilowatt, then you see around 50% hours operating hours are needed. And if price is threefold lower, then it is reached quite early. And this graph is based on a fixed electricity price of $20 per megawatt hour. And here we see that electrolyzer system cost is $200 per kilowatt. So this is fixed, but electricity prices from $10 to $40. And if it is $10, then we are reaching this goal quite early. But if its price is $40, then it may be possible that we can never reach this price target of $1 to $2 per kg. And interestingly, one of famous industrialists in India, he offered this unbelievable price of $1 per kg in coming year. And he predicted in next 3 to 4 years, he will be able to offer this green hydrogen with price of $1 per kg.
Sir, this is
That will
Kundan.
be.
Sir, this is
Yeah,
Kundan. Now
yeah.
you have only 8 to 9 minutes as for your time commitment, sir. So maybe you can conclude in 1 minute for your slides, such that few participants may ask some questions. Okay, sir.
I would like to then jump in and sorry, Dr. Kundan, you have not given me early warning, so I need to then jump in. My latest. I need to talk about this contact.
Okay, sir. No issue from my side, sir. No issue from my side. If you are comfortable, you can carry on, sir. No issue, sir.
Yeah, I will take maybe 2-3 minutes for talking about this new technology.
Okay, sir. Your convenience, sir. You can leave as per your choice.
Yes.
Okay, sir.
But I feel sorry because you have not warned me earlier, so I was just not looking on the watch. So okay.
Okay. No issue, sir.
Never mind. So we will now look into this drivetrain technology, and I will talk about this latest contactless type of synchronous motor, which is Reality and BMW i3 variant and Journal motor. Here we are using a conventional synchronous motor, and we are not exciting rotor through slip ring and brushes. Instead of, we are using a contactless power supply. So here you see that this is the contactless synchronous motor. We are having a rotating transformer, and this transformer is worked through these ferrite cores. And how will provide this contactless power supply to the rotor? That I can go through this slide. Here you can see.
Can you please go for the previous slide, sir? Request you please go for the previous slide.
Yes.
Please explain, sir, once again. I'm requesting you.
You see, this is the housing. This is the stator winding. And here in the end, you are having these ferrite core end. So there is a stator. You are having these ferrite cores, and in the rotor assembly also you are having the ferrite core. You see this like a bobbin. This is the stator. In the stator assembly, you are having this structure, and in the rotor assembly, you are having this structure.
Thank you, sir. Thank you so much.
So this is the fixed part, and this part is rotating, and you are exciting this ferrite core, and through contactless high frequency signal, like you see our, for example, our smartwatch that is charged with this ferrite core structure. So this part is fixed in the stator, and this is the moving part, and through we get this electromagnetic induction through high frequency input. So how it works? In conventional motor, we are having an inverter from DC to AC, but here we are having a additional hardware where you are having a not one inverter but a small inverter unit which is injecting a constant current based on the excitation level requirement, and this energy is transferred through high frequency signal injection. So from this ferrite core wireless power transfer, we control the rotor excitation. And interestingly, for achieving this, you can indirectly rely on the current injected through this inverter unit. And here you can see that this rectification unit is installed in the rotor, and it is connected to the ferrite core. And in the stator part, we inject this high frequency signal. This is you can see inside view of stator and rotor coil arrangement. So you see here, this is your lease wire with bundled rotor winding, and here in the end you see this is the stator wire, stator ferrite core and stator winding. And this main inverter that is controlling the desired rotor current, and then actual rotor current is feeding to the main inverter, and it also take into account the rotor temperature, and it's also account for the IGBT module temperature. And this rotor current controller that comes into play in the starting when we need to have high starting torque, and in the field weakening region and high frequency speed, high speed region, that current is minimized, or that maybe it can live in with residual magnetism. And here you can see some of the result of this. We are with the feedback current. So you can see the phase U with the green. So this is the phase U current, and phase to phase voltage, that is this. You can see the topological voltage, and this is measured at the speed of 7,000 RPM. So now I will conclude my presentation. That global mega trend, they are creating a space for e-mobility, and green technology based e-mobility is future of sustainable world against climate change. And power electronics and electrical drive is an essential component in the success journey of e-mobility transition for setting this world safer for our next generation. And these are some references which I took for this presentation. And now I will open the floor for the questions. Thank you very much.
Yes, participants, you may ask few quick questions. If you have any query, please go ahead with your queries.
who has asked me this in the presentation? Maybe we are having time to explain and specifically address the questions. Who asked me for this contactless synchronous motor details? Please ask. Tell me your name and affiliation. Who asked me the question?
Please, if you are available, please ask your query. If you have something, some comments, you may.
So this is Naveen. I would like to ask one question.
Please
Yes,
go ahead.
Naveen, please go ahead.
Yes, sir. So what is the role of battery battery vehicles, like in case of heavy vehicles like lorries, buses? So if you can shed some insights, so will it be like how it will be different from light motor vehicles like cars or bikes?
You ask very relevant questions because we, in case of heavy vehicles like truck or this load carrier vehicles, we cannot make them fully electrical until we are having infrastructure where we are having a separate electricity supply by either by overhead wire or underground sliding wire. But there is a huge scope, and what we can see in India also, like Ashok Leyland and other companies are doing, like we can provide electric drivetrain together with the conventional transmission circuit, gasoline-based power transmission circuit, and we can optimize the efficiency for fuel. So we can use the batteries, but not in that capacity where we can replace all gasoline-based engine. But of course, that will be our target, but that is needed a big infrastructural change, because if you want to make self-sufficient or fully electrical operated these big trucks, then the battery price and the technological, we can say, challenges to meet the cost and offer the affordable solution to the market. That is now it is not still meeting the requirement. So there is a lot to do on that part, and maybe one possible solution is when we see that our surface transport minister is talking about to making this fully electrical corridor from Delhi to Mumbai, where he can think of providing some electrical infrastructure so that this electrical supply can be supported instead of EVs.
Thank you, sir, for your elaborate explanation.
Yes, thank you.
Any more questions, please?
So it is Rob this side. Hello, am I audible?
Yes, you are audible, sir.
Yeah, so my question was related to green in the electric vehicles. So my question was, in lithium-ion batteries, we see that there is a lot of construction uh, and everything going on. In fact, it requires a lot of energy for manufacturing a lithium-ion battery. So my question was pertaining to green in electric vehicles. So is it really green if we compare the internal combustion engine to the electrical vehicle? So is it at par or is it better? Because if you see the energy and the environmental effect of mining and doing everything. Thanks a lot.
Yeah, when you're talking about lithium-ion batteries, so and then you relate you compare the definition of green. When we say that green, then this definition comes from we are not using fossil fuel. So if we are relying on the renewable, then we are saying it is green. But of course, what you are you are just having a point that lithium-ion battery that is not safe. Well, like lithium is not good for health, and there are hazards when we are doing the mining of it. And for the people who are working in the mining industry, they are having some disadvantages, and that's why there is a worldwide research is going on to get rid of these like lithium-ion battery. But you know that it is the last 20-year consolidated effort of scientists and battery experts, battery technology experts. So it will take time, but we are going to see the next wave of battery technology, which are more safer. But this is one thing I would like to say again, that green technologies that is related with the which type of energy you are using. Are you using any fossil fuel, fossil source? Then it is not green. So battery and green technology, they are two different things. We cannot mix it.
Thank you for the clarification, sir.
Anyone else, please?
If the participant having any question, then they can write me a mail also. Here is my email address. They can be connected with me and ask me question. I will happy to answer their question.
Okay, thank you. If there is no any more questions, already, sir, I have requested to participants, if they have any questions, they may send to you in your mail or to me in my mail, so that I could convey to you. Okay, sir, thank you so much for your support, sir, and for your wonderful, excellent talk. We really learned a lot of things based on the electric mobility. So, if may I ask you to stop your sharing, sir?
I will. And then thank you so much. And best wishes for the participant for remaining courses. And see you later. Bye for now.
Okay, sir. Thank you so much. And I just wait, sir, for a second. I would like to share.
Sir, excuse me, sir, on question.
Yes, sir. This is a appreciation of a token of appreciation, sir. Thank you so much. And other formality of document. Okay, sir. Other documentation formality I will be touching with you, sir.
Yes,
so thank you
very
so
much,
much.
Dr. Goutam.
Okay,
Yes.
thank you so much, sir. Okay, sir. And participants, it is okay if you could write a mail.
Sir, I have a
quick question.
sir.
Yeah, quick question. Please do it quickly, sir. Please. Please, sir, quickly. I think speaker has left, I guess, because he has some. Okay, sorry for that. You may put a mail to me or to directly to him. Okay. Okay. Thank you so much for your active participations. We will start next session at 1:30. That is a PMBLDC motor control for light electric vehicle. That is session 2. Will start at 1:30 and will be delivered by Dr. Ritesh Malkesri, VNIT Nagpur. Okay, sir. Thank you so much. Thank you so much to sir and ma'am who were present here, all the participants. See you at 1:30. You may join early. The link will be on. Okay. Thank you so much. Yes, presentation slides and video recording will be. Okay, presentation slides. We need to request to speaker if it is allowable from him or from his side, or else the video recording we will be sharing you. Just wait for some time because it will take some time to process. If we will be able to submit, we will be able to share you in between, or else after finishing the works of FDP, I will share everything once it will be compiled. So enjoy the sessions. Everything will be provided to you but please wait, be patient. Okay, thank you so much. Thank you so much for your active participation. Now session is closed for the first talk. We will start at 1:30. Thank you so much for joining.
Thank you, sir.
Thank you.